So yeah, I'm Tyler McMullen, and I want to talk to you about why I think serverless and WebAssembly are actually kind of made for each other. And I know the answer to that, and it's because I helped to make WebAssembly, so I know that they are made for each other. It's kind of a spoiler for the end of the talk here, but cool. So if you don't know who I am, that is exceedingly reasonable. I'm the co-founder of Fastly. We've been at Fastly for almost 14 years now. If you don't know Fastly, that's slightly less reasonable, but we are one of the world's first edge clouds. That entails CDN services, edge security services, as well as edge serverless. And so basically running your code, your functions, whatever you want to write, across thousands of servers across the entire world simultaneously. It's a pretty cool system. So my job at Fastly for the last 13 years has been as the CTO. Part of that job was helping to design exactly how the architecture of the thing actually works. And more specifically, I've been working on WebAssembly and our serverless platform for the past 8 years at this point. However, last month I made the choice that I was desperate to get back to writing code again. And so I stepped down as CTO. I am no longer the CTO of Fastly as of last month. I am instead actually on sabbatical. So I am here on sabbatical. I'm essentially on vacation at the moment, and so obviously I'm spending my time talking at conferences. That's what I do. The reason I'm telling you this is actually just to explain the perspective that I'm coming at this from, which is to say I'm not going to talk much about Fastly here. I am rather going to talk about the ecosystem and about WebAssembly itself. However, at the end, I think we'll come back around to it, and maybe I can try to make a case for why this is also important, especially for an edge serverless platform. So, okay, I'm here mostly to talk about WebAssembly. So, how many people know about WebAssembly here? A decent number of you? Okay. All right, so half the crowd. That's not bad. That's significantly better than it was a few years ago, is what I will say about that. Most people know about WebAssembly from the perspective of hey, it's a new kind of alternative-ish to JavaScript in a browser, which is fair, and that is true. I think that if you look at what WebAssembly is, not just what it does, but what it is, it might make more sense as to why I think that it is especially useful for serverless type environments. So just a real quick dive into WebAssembly. Okay, so WebAssembly is actually really simple. A WebAssembly module is composed of some code compiled from whatever language you like that happens to compile to WebAssembly, which is most at this point. It specifies functions that it imports from the environment or from elsewhere. It specifies functions that it exports to the environment or to elsewhere. And it has some amount of memory associated with it. And that's it. That's all of a WebAssembly module. WebAssembly code is actually really small. It's small and really well defined. This is the entire syntax specification, the abstract syntax specification for WebAssembly. It all fits in that little box, right? What's even more impressive actually is that that is the entire semantics of WebAssembly. And I know that that looks complicated, and it is in fact complicated. This is the small step semantics, reduction rules of WebAssembly. But this page is literally every piece of information you need in order to write a WebAssembly interpreter. You could write an entire interpreter based off this, and it would run WebAssembly. So that is how simple it actually is, which to me is pretty impressive, even if it does look complicated. Okay, so a number of years ago, sometime after WebAssembly had been created and had already been deployed into browsers, a small group of us realized, basically we had a realization around the same time. And that realization was that WebAssembly had the potential to be really important outside of the browser, not just in the browser, but outside, right? So we founded a nonprofit, which is called the Bytecode Alliance. That is the Bytecode Alliance logo. It's a group of about 30-ish, over 30 companies, I think, at this point. And the idea is that we work together to create and maintain all the tools that go into making WebAssembly work outside of the browser. So if you're not using it in Chrome or in V8 or something like that, we are probably maintaining the tools that you use. I sit on the board of the Bytecode Alliance, among other things. One of the main things that we work on together there is something called the WebAssembly component module. So this is let's call it, it's like another simple layer on top of what is already a simple thing. And I promise this is all gonna make sense momentarily. Right, what is a component? Why is a component? Well, WebAssembly is designed to be highly portable, right? So it'll run on basically any processor that you put it on at this point. There's tons of compilers for it out there. Tons of compilers, tons of interpreters. But portability is actually a really tricky word, because yes, it can run on any processor, but it also doesn't specify almost anything. It doesn't really box you in and say hey, here's how this should work. It just says here's a rule for these literal instructions, that's it, right? It doesn't really say anything about how it interacts with the world outside of itself. So let me give an example of that. Okay, you remember this is the abstract syntax tree. One of the downsides of being so simple and so small is that a lot of times things are left unspecified, even intentionally. So let's zoom in here. So that is the entire set of types for all WebAssembly programs. So you have numbers, or what's this? Other numbers. That's right. That's all of them. Floating point numbers or integers. That's it. That's all you get, right? And that's fine. That's actually enough. In most assembly languages, that's kind of how it works, right? You think about registers in a processor. You basically get floating point numbers or you get integers, and that's about it, right? But much in the same way as a literal processor, it also leaves a lot of things unspecified here. So, for instance, which means when we look at this diagram, when we talk about import and export functions, we're really talking about functions that take a number and return a number, or maybe they take two numbers and return one number, right? They're these are really low-level functions, right? So if I wanted to say take a string and return an error type, that's not a thing, right? So this isn't a bad thing. What it means is that this is kind of left up to the languages. So Rust might say, oh, okay, well, a string, that's composed of two integers, one of which is a pointer and one of which is a length. C might say, it's just a pointer, right? Ruby might say it's something totally different. JavaScript, well, yeah. Yeah, so basically every language might represent those types differently, right? And so if I want to say import, export a function from one language and import it from another language, that's just not a thing that you can do. What's interesting about that is not just that it's about connecting two of these modules together, it's actually about how you interact with the environment. So if I, as a platform provider, wanted to make a function that says hey, send an HTTP request, well, how JavaScript represents an HTTP request is different than every other language, right? Does this make sense? Let's pretend it does. Right, not a thing. So one of the primary goals of the WebAssembly component model is to create a way to wrap a WebAssembly module and say, this function taking a number and providing a number is actually taking a string and returning an error, right? And to then provide a way for us to be able to connect programs together more effectively, like so, right? So basically the idea is that if we wrap them up in these little wrappers around them, we can say I have a JavaScript program here that is sending out a string. Rust doesn't know how to interpret a JavaScript string, but I can generate a little bit of code in the compiler that can translate from one to the other back and forth, right? And so that's what the WebAssembly component model effectively is. So who gives a shit? Right, so that was some fairly dense, kind of esoteric information, and probably half the crowd here is now wondering, why are you talking about this? This is irrelevant to my life. At this point, I would like to take a step back and say, it seems to me that the majority of talks here today, as well as at most other conferences like this, are either serverless providers, platforms, who are trying to talk to developers, or they are developers who are trying to talk to other developers. What I would like to, basically, platforms to developers or developers to developers. For the purposes of this talk, I actually want to try to talk to both groups. And there's a reason for this, providers and practitioners. Let's call them Alice and Bob. So Alice is a platform provider, a developer working at any of the major platform providers, or even minor platform providers. And Bob is a developer who is using that platform, right? So what are the things that Alice and Bob care about? Well, if you were to ask developers either who are just working on an application or who are working on a platform what things they care about, I guarantee one of the top 3 things for both of them would be security, right? Everybody cares about security, or everybody says they care about security. However, I think things start to diverge a little bit at that point, because like the things that a platform developer cares about and the things that an application developer care about start to be at odds with each other. So, for instance, if I am working at a platform, I would like to have to maintain and develop the least number of languages possible to run on my platform, right? However, Bob really wants to use the weird esoteric language that his team picked 6 months ago and that he is now stuck with, right? Okay, what else do they care about? Well, one of the other things Alice would care about is minimizing like the API surface. Alice wants to maintain the smallest set of APIs, and this also ties into the number of languages, because in a traditional serverless environment, if you have a bunch of different runtimes and a bunch of different APIs, you're looking at like basically having to maintain an API, every API for every language, essentially, right? Whereas, of course, Bob is like, hey, don't make me work at this, just give me the thing that I want to be able, like, that I need to be able to get my job done, right? Okay, let's look at these individually real quick. So, security is interesting because I would actually argue that the things that we say when we say security actually vary quite a bit when it comes to like Alice versus Bob in this case. When Alice is talking about security in terms of a platform, what Alice actually cares about is protecting the platform itself. That is generally true, right? So like when Alice thinks about the technologies that have to go into protecting and like basically isolating code that is running on the platform, Alice is worried about, hey, how do I make this code not break out and like break into the rest of my system, right? And Bob cares about that too to some extent, but like mostly it's just, this is a thing that's outside of Bob's control. When Bob talks about security, I argue that Bob is actually talking about application layer security. Bob is talking about things like, hey, how do I, like my threat scenario in this case is actually about end users a lot of the time. Or it's about other developers having things like supply chain attacks, which if you've been following along or had been following along with the like XZ debacle, that's like a really good example of that one, right? So I would argue that WebAssembly is in an interesting place to be able to address both sides of this, which is not a thing that has really been possible before. Like when we talked about, like when we were initially building early versions of serverless platforms, a lot of these things were built on top of either VMs or on top of like containers, right? And those are fine. Those are great technologies for like, you know, very, how would I say it? You know, non-granular isolation, right? You're not bringing up one of these per library. You're not bringing one of these up per request, right? You have the thing, you spin it up, and it's there to protect it. It's fine. Okay. WebAssembly, though, when we were talking earlier about the ability to take a component and have it talk to another component, WebAssembly is lightweight enough. This is the kind of thing where I could not only use it to, say, isolate code coming into my platform, but I, as a developer, an application developer, could also use it to, say, isolate a library inside of my application. So if I were using, say, XZ, or before XZ, I used to say leftpad, for those who are old enough to remember the leftpad hack, there's no reason why, like, inside of a WebAssembly type environment, you couldn't say, put those libraries into their own component and just talk to them in that way, thus completely isolating your code from them. Okay, let's look at another one. Runtimes, right. So again, Alice cares about minimizing the number of runtimes, languages, and Bob cares about like having the thing that Bob's team is using accessible to them. Well, again, one of the things that WebAssembly is here to address is that like, I would argue that like a platform developer shouldn't have to think about the individual languages. The fact that like we have every language and every version of that language and like that's a thing that like a team needs to think about and maintain is crazy, right? Because what that effectively means is that you need a team of developers per language, right? And that's how only like large serverless platforms tend to win, is because you end up getting like, they're the only ones who have that like breadth available. I would argue, though, that this is, again, one of those times where WebAssembly can help, because once you have a WebAssembly platform, any language that compiles to WebAssembly now works in it, right? So this is one of the goals here. And then APIs are kind of a similar story in this case. Again, Alice wants to minimize the number of APIs that they have to maintain, and Bob really wants everything to be available as quickly as possible. So this is where I think WebAssembly and the component model really shine, and I think, give a pretty good example for this one. So one of the things that comes along with this is something called WASI, the WebAssembly System Interface. It's a series of standard APIs that we have been working really hard on in the WebAssembly standards organizations to standardize, right? And the idea behind this is that you should be able to standardize a set of things and have them work across multiple different platforms. So when we talk about things like HTTP, if I can have a standardized HTTP interface that works on Fastly, and it works on AWS, and it works on every other platform. Nginx actually is one of the most recent ones to ship this thing. It means that I can take a component that I wrote that runs on Nginx, and I can just deploy it on Fastly. Or I can take something I wrote for Fastly and deploy it on AWS or whatever else, right? That's kind of one of the ideas here. But one of the core, again, this, I need to figure out how to describe this part. This is such a tricky, this part is such a tricky thing to explain. But at the core of what I'm trying to talk about here is the concept of virtualization, right? And when we think about virtualization, a lot of times people think about non-granular virtualization. They think about virtual machines, right? But I'd argue that what we are pushing toward with this highly granular isolation and highly granular sandboxes is the ability to virtualize smaller and smaller things. In the past, years ago when I was talking about WebAssembly in the early days, I would describe it as a VM was virtualizing an entire computer. And a container was virtualizing an operating system. And WebAssembly was virtualizing a process. I actually argue we're getting even smaller than that at this point, right? So here's kind of how I'm trying to describe this. Let's say that on the left over here, these are the APIs that are available from a platform that you are currently using. And your code is over here on the right, right? And this is all that's available. There's no file system. There's no nothing, right? But because of the way that WebAssembly works and the way that these components work, we can create our own APIs on top of this. So, for instance, let's say your code that you have deployed onto this platform really needs a file system to exist, but the platform doesn't provide one. Well, again, because there is a standard way of defining a file system, and because I can write multiple components and connect them together, I can just make my own, right? And it might be something really stupid simple. It might literally just be, let's pretend that defining a file system is exactly one function. Obviously, that is not true. But let's say, for the moment, the simplest version of this is literally just, hey, let me make a read file that returns an error. Great. That doesn't do anything, but at least you have a file system to build off of now. But because, again, components can be chained together, there's nothing that stops me from then saying, well, OK, I actually need, the main thing I actually really need here is I really need dev random to exist on my computer. Well, it doesn't exist because there was no file system, but there's nothing that stops me from, say, making another component that literally just says, oh, is the file I'm trying to open dev random? Well, great, let me get random bytes from the random API that my platform provides me. And I've now created my own dev random, just like that. Or we can go a step further and we could say, well, I actually need configuration files as well. Well, OK, we can chain that into this loop as well using the HTTP interface up there and say, hey, let's download our configuration files off of S3. And it just appears as a file system, even though no file system exists on that platform. That's the idea here. And so essentially what I'm trying to say is that WebAssembly is an interesting way to be able to start addressing the problems of both the providers and the practitioners simultaneously. frequently, a lot of the time, providers and practitioners have always had like technology that effectively was like, it was essentially fighting against one side or the other, right? But the whole idea with WebAssembly and serverless is that with WebAssembly, the tools you use to build your application are the same tools that are used to build the platform itself. And it is not like the platform gets to use one set of tools and you get the tools they provide to you. It is literally all the same tooling. So the last thing I'll say about this is like, Fastly's goal since the beginning has been to make the edge feel as if it is part of your infrastructure, to make it feel as if it is like just one of your computers that you are deploying code onto. It is part of the thing that you're already building, right? So WebAssembly has given us a very powerful way to do that. It lets you take the platform as it is and then turn it into what you need it to be, using all open source tools. So that's about all I got. So I want to say thank you and that I am open to questions.
All right, well, thank you, Tyler.